Pre-college, radians. Express 140 degrees in radian measure. So you need to remember how to convert back and forth from degrees to radians. To convert into radians, we multiply by pi over 180. And that's just something that needs to be memorized. And so what would end up happening is this would be over 1. You multiply the top, you get 140 pi over 180. And then you need to simplify the 140 over 180. So you could type into your calculator 140 divided by 180, and then do the math, enter, enter to convert it into a fraction, and it should come out to be 7/9. And we're just going to leave pi where it is. Now, if this said, what is it in radian measure to the nearest tenth, then we would actually type in 7 times pi in our calculator divided by 9 and get some decimal that we would then round. But basically, what you're doing to convert degrees to radians is you're multiplying by pi over 180. And essentially, pi doesn't do much. We usually keep it in terms of pi, so you're basically dividing by 180. And so you divide this by 180, simplify it down to its simplest fraction with your math enter, enter function in your calculator, and that'll get you, 7 pi over 9. Going the other way, converting radians to degrees, there's actually two options here. So let me show you both methods. First method is I can take 2 pi over 5, and what we did this time was we multiplied by pi over 180. Well, this time I do the reciprocal of that, which is 180 over pi. And what's going to happen is the pi's will cancel out. I'm left with 2 times 180 over 5, which then simplifies down to 72 degrees. Option number 2. Now, this will always work, but option number 2 is, let's say, 2 pi over 5, is remembering that in radians, pi is 180. So if pi is 180, then I could just replace the pi with 180. So, and we actually see that that's what we have here. Instead of doing this, I could just replace pi with 180, and that is a little bit quicker. It kind of skips a step. So then the obvious question is, why don't we just do this every time? Because radians don't have to have a pi in them. Kind of like this first question where I said, what would it be in radians to the nearest tenth? Well, it'd be, 7 times pi over 9, whatever that decimal happens to be. They could multiply by pi. So like here they're giving us a radian value that has pi. But what if they gave us a radian measure that did not have pi? We can't replace pi with 180 if there's no pi to begin with. So that's why this is kind of the foolproof method of timesing pi over 180. And if you have pi's, they cross out. If not, then that stays there. And we're going to see this in the next example. But if pi is present and you're converting to degrees, you can simply replace pi with 180. This next question says, all right, here's 2.5 radians. What is it to the nearest tenth of a degree? So 2.5 radians, I cannot replace pi with 180 because there is no pi to replace. So my only option when there's no pi is to do the times 180 over pi option, like what we did here in our first case. Now, no pi's are going to cross out here, which is okay because they actually want this to the nearest tenth. So they want us to do 2.5 times 180 divided by pi. First, what is 2.5 times 180? I got to use my calculator over to the side. I don't have it on the screen here. So 2.5 times 180 equals 450. So we got 450 over pi, and then to the nearest tenth, I'm actually going to now divide my answer by pi and get 143.239448, so on, so on, so on. But to the nearest tenth is 143.2. And that's the answer they wanted. And this is a really important question, and I hope you're really paying attention to this because students have no problem converting radians to degrees when there's a pi to replace. It's easy. Just replace pi with 180. But when there's not a pi to replace, they tend to get very confused. And so remember, this is what you have to do. Times 180 over pi. And you could just do that every time as to form that habit. But I want to show you everything that I could show you on how to solve these problems. All right, so that's how to convert back and forth from radians to degrees. But there's one other thing that we tend to use radians with, and that is something that we call SOAR problems. That we use it to solve these. We have this formula, which is something you'll be adding to your reference sheet when we get into test prep. S equals theta r. And this is a formula for arc length. So S is your arc length. So arc length, like the circumference of a circle, the measure of the outside of a circle. S is the arc length. R stands for radius, not radians. But theta, we know theta stands for the angle. But not just that, it's the angle in radians. It's important to remember that S equals theta r, which we call the SOAR formula. The SOAR formula is a radian formula. And that's what trips people up sometimes, because if they give you an angle in degrees, you have to convert it to radians before you can use this formula. So S equals theta r. The arc length of a circle equals the angle in radians times its radius. So you definitely need to know this formula. And so let's see, let me just rewrite it one more time, and then let's read this question. In a circle with a radius of 2.5, so there's always two things over here, theta times r, and they just gave us radius of 2.5, so that's 2.5. A central angle has a measure of 5 radians. So they're giving us the angle in radians. Again, notice there's no pi, so if I wanted to convert it to degrees, which I'm not, but if I wanted to convert it to degrees, I'd have to do what we did here, the times 180 over pi. But this formula wants radian angles. They gave me a radian angle, so I'm good to go. What is the length of the arc? So what is S? I apologize, my S's look like 5s, but this is an S. So S, the arc length, equals 5 times 2.5, and 5 times 2.5 is 12.5. So that's the answer. But let's look at one more. S equals theta r. And you know it's an S equals theta r question when the question is referencing a radius, an angle, an arc length. Okay. And again, arc length is if you have a circle, I'm talking about the length of the actual arc. Very similar or exactly like circumference of a circle. So S equals theta r. Let's see. In a circle with a radius of 5, so this time they're giving us the radius again. This time the radius is 5. And a central angle that has a measure of 60 degrees. What is the length of the arc? So what people do wrong is they put a 60 in here and they multiply 5 times 60. But that doesn't work because the angle has to be in radians. So I need 60 degrees to convert into radians. What is the radian measure of 60 degrees? Well, the way I convert degrees to radians is I do times pi over 180. And 60 times pi over 180 is 60 pi over 180, which will simplify down to pi over 3. And that's actually one of those radian measures that you might have memorized, 60 degrees. Maybe not yet, but you probably will eventually. And the shortcut to that is, remember, pi is 180, and 60 is a third of 180. So pi over 3 makes sense because it's a third of pi, a third of 180. Well, 60 is a third, and so on. All right, so anyways, so the angle in radians is pi over 3. So that means my arc, pi over 3 times 5 is 5 pi over 3. And that's my answer. Now, if the question was more specific and said, what's the arc to the nearest tenth, I would do 5 times pi over 3. And let's just find out what that is. Anyway, so let me type into my calculator now. 5 times pi. So 5 times pi divided by 3. It is an arc to 5.235, let's say about 5.2 to the nearest tenth. Now, the question didn't specify what they wanted. So this would be my answer because I don't want to round when it doesn't tell me to round, and this is an exact answer where this is an approximate answer. But that's how we'd go about it. But the key is to remember that the angle has to be in radians. All right, that's it for radians. We'll play with this tomorrow. See ya.